Now we're going to start doing some selections, because generally you may want to do things to a few atoms that you don't want to do to all atoms in your structure. Frequently you're going to have to type in order to do your selection. And so you may, you're going to end up using the command select space, and then you give your name. And so that's your name for the selection. So I'm going to have a subset of atoms, and what do I want to call that subset of atoms? Space equals, and then space, and then you give your criteria. How do I define that subset of atoms? And what we're going to do is we're going to look at different ways we can define criteria by typing help selections into the PyMOL window. So if we come up here, either in the tickle interface or the graphics viewer, you can type help selections and hit return. Now right now that's just put everything up here in the tickle interface, but it can be hard to see all of that. So if you come down and click on your graphics window, so your graphics window is active, then you can hit escape, and you will toggle that text display up into your graphics window. But you can hit escape again and toggle off. So you can toggle back and forth between your text. So you'll see that we have selections by atom names, by residue names, residue identifiers, RESI, or by residue number. You can use chain. Seg ID you'll almost never use. You can do it by element, ELEM. Those are going to be the main selection criteria you use. So I'm coming back to my PowerPoint display here. So selection, if you're selecting by residue number, these are just examples, you can select residue 15 and residue 145, or you can select a range, 15 through 145. The second option is a range. You can use residue name, you can use atom name, you can use chain name, or element name. Now you can use AND, or not. You can use the plus or dash, or you can use these symbols. The ampersand is an AND, the bar is an OR, and the not is the exclamation in front. So let's go through these complex selections down at the bottom. RESN, residue name lysine. So that's going to be all residues named lysine. If you have an AND there, either the ampersand or you have AND typed out. If you have residue name lysine and residue number 51, your selection is only going to consist of those residues which are both lysine and numbered 51. So any lysines that are not 51 will not be in your selection. Any residues 51 that are not lysine will not be in your selection. Everyone see that? So you'll have only those residues which fit both criteria. It's a lysine and it's number 51. The OR is different. You're going to get all lysines and all residue number 51, because only one of them has to be true. RESN lysine is going to take all the lysines, or residue number 51 is going to take all the residue 51s, regardless of which residue it is. Do you understand the difference between an and an or? A not says I'm taking everything that's not a residue lysine, which means the other 19 amino acids I'm taking. Okay, so that's how you form your criteria. Now we're going to select, here's the command that I want you to type. 2BCJ_GQ is the name I'm giving that subset of atoms. It's a G alpha Q, and so I'm calling it 2BCJ. It's from that PDB file, _GQ, for it's a G alpha Q. That's my name that I'm giving it. You could call it junk if you wanted. You could call it polyQ, you could call it anything you want, space equals space chain. That's my criteria. I'm going by chain, space Q. The chain name is Q. Now in this case, the experimentalists did not name the chains A, B, C, D. They named G alpha Q, chain Q. And so, and you can find that out by looking at the PDB record. But I already know that because I did that work for you. So if you select 2BCJ underscore GQ equals chain Q and hit return, you should see your yellow chain come up with pink dots. Everyone see that? Okay. Now if you come here, you should see a new line pull up in your window, which it has parentheses in it. That's a selection. The parentheses means it's a selection. It's a subset of atoms in the object. Now, if you toggle, you can toggle this 2BCJ underscore GQ on and off, and you'll see that those pink dots go away. Those pink dots are showing you which atoms fit the criteria chain Q. So you can see which atoms are fitting your criteria by toggling on and off. Now, if you toggle your object on and off, what's happening? The whole thing's disappearing, right? And so toggling an object on and off, if you have more than one object and you don't want to be showing all of them, you can toggle it off. But toggling a selection is toggling on and off the highlighting that shows you what fits that criteria. Okay, do you see the difference there? So we have a selection. Now we're going to come down here. So that's how you make a selection, and you can do different things with that selection. You can show it in spheres, you can change the color, whatever you want to do. We're going to make a couple more selections, and then we're going to start comparing structures. So this time, what I'm trying to show you is different ways of doing different things. Sometimes it'll be easier to type a select command to do a selection. Sometimes it's easier to use the sequence window viewer. And so you need to figure out which one you're more comfortable with. In PyMOL, there are almost always several different ways of doing what you want to do. So if you learn all of them, you'll learn when is it easier to type the command, when is it easier to use the sequence window viewer. Now, we're going to use the sequence window viewer. We're going to make two new selections. One is 2BCJ underscore GDP. The other is 2BCJ underscore GDP contacts. And let me show you how to do that. Okay. So we're here in our PyMOL window. The easiest way to turn your sequence on is down here in the lower right-hand corner. Right down here is an S. So you can click on that S, and you should see a sequence pop up here. Everybody see that? Now the green residues are your GERT2, that's chain A. You'll see 2BCJ is the object, chain A. This is the residue number. Your first residue is residue 28. And you can scroll on down, and then you'll see the color change to cyan. You'll see this is chain B, and that's our G beta there. And then a very short G gamma, and then your G alpha Q. And then down at the very end, your G alpha Q has some ligands bound. It's a G protein, so it has a guanine nucleotide bound. Now this is a guanine diphosphate, GDP. Generally the molecule's in the off state with GDP bound. When it has GTP bound, it's in the on state and it's signaling. Now this particular conformation is actually a transition state. That is, G alpha has an enzymatic property, a function. It can hydrolyze the GTP to GDP. The transition state is in the middle of that enzymatic reaction. That's the transition state of the reaction from GTP to GDP. So crystallographers can mimic the transition state by binding aluminum fluoride. So that has characteristics of the third phosphate, but the conformation is more like the transition state. So the ALF is aluminum fluoride, and there's a magnesium there. So these are your ligands, and there are some waters there associated with that ligand. Now, if you have 2BCJ_GQ turned on, you'll see these residues are already highlighted. You see them there? Now, we can actually turn them off or turn them on. We're editing 2BCJ_GQ. We actually don't need to worry about this selection. I want you to turn off the highlighting for 2BCJ_GQ. Now, if you click on the GDP, what happens? You pull up a generic selection. And then you can click on the magnesium, aluminum fluoride, and the 5 waters. So highlight those 5 molecules into a generic selection. You can either edit a selection that's already there, or if you turn it off so you don't see it highlighted in your sequence viewer, if you start clicking on residues, it goes into a generic selection. Everybody see that? So we now have a selection SELE. We can come here to Action, and we can rename that selection away from the generic selection. You need to backspace, type 2BCJ_GDP, and hit return. So we have a new selection. Everybody see that? Pretty easy. Now, we're going to turn this off. We're going to do the same process again, and this one we're going to rename 2BCJ_GDP and then contacts. Okay? 2BCJ_GDP contacts. Now, what we're going to do with this selection right now has our GDP, our magnesium, our aluminum fluoride, and the 5 waters. And you can see this is sort of sitting in the middle of the molecule, right? Down there you see the highlighting. We can come here to 2BCJ_GDP, and we can show spheres. And you'll see it show up here. You see those yellow spheres there. Let's color those spheres by element. Let's come down here to this blue thing. Second from the bottom. And it now pops up a little bit from the yellow. Everyone see that?